Good evening, class. This lecture is going to be Chapter 2 of Understanding Psychology. And I have to say that this is one of my favorite lectures to give. I'll give a little bit of perspective about why this is my favorite. I graduated from college with a BS in psychology and was really interested in research and in college, I did some cognitive neuroscience research looking at depression in adults. I also did how research with a woman who sort of looked at how children understand um, play, and also if you show a child a room that looks like, a room with a couch and a chair, and then you show them an exact model using a little toy house, if that makes a difference in sort of their processing of where to find things during a hide and seek game. So that wasn't enough for me in terms of research. So I ended up going to Duke University and doing cognitive developmental neuroscience, looking at how children understand numbers. And so I did EEG work, I did fMRI work, I did ERP work, which led me to my master's, where I looked at how babies process spaces, and how my work really focused on how infants process emotional information from different faces, different meaning the race of the face. So can they match a happy sound with a happy face if it's a face that's familiar to them, that's of the same race, or if it's a different race? And I was really focusing on sort of the perceptual biases involved in there. So by perceptual bias, I operationally define this as how the brain processes the face itself. So there was nothing about racism in there. So I bring this to your attention because at one point in the semester, I'm going to use this as an example to sort of show how the media took this too far. And when the article was published saying that 9-month-old infants could not match happy sounds with happy faces for African American faces, but they could for Caucasian, that babies were racist. And this was all over the news. It was on Yahoo News, it was on Jezebel.com. So it's really important in terms of becoming a critical consumer of psychology that we think about this. And it was even on This American Life. So I'll sort of start with that point. But before we go there, I will let's take a step back and talk about psychological research and what is psychological research. So when we think about psychological research, it's really important to answer two major questions of what is the scientific method and what role do the theories and hypotheses play when completing psychological research. So the scientific method is the approach that psychologists systematically use to acquire knowledge and understanding about behavior and other phenomena of interest. That's a very good definition. However, it's kind of wordy. In a sense, psychologists are systematically testing our understanding and knowledge about humans, or about how humans process information. And I think the key thing here is systematically. And in particular, the systematic piece talks about protocol, operational definition. There is an order, there are steps, there's a hierarchy that you need to follow when completing the scientific method. So, I like to think about science as a scientific, or the scientific method, as it's a story. So, the steps to me fall out to posing a question, Then you design an investigation for that particular question. So you're systematically using the same steps, but you're focusing on one question. You collect the data by implementing the study, you analyze the data, and you share the results. So when sort of pairing it back together with this idea of theories and hypotheses, it's important to note the difference between a research question and a research hypothesis. So they say on this figure, let's see, the pen color will be red. You know, you're identifying questions of interest. So you can look at, for example, my research. I knew that infants, based on the theory of what we call perceptual narrowing, which is that infants have this sort of inherent ability to process all human faces, even from when they're born. However, their ability to perceptually process these faces and the information from it fine-tunes across the first 9-month period. And it is really fine-tunes to what's in their environment. So it's almost like a funnel. So I knew that from previous research findings that there was something called the other race effect, and that 9-month-old infants could not differentiate between two African American faces that were similar, but could between two Caucasian faces. I was curious and wanted to get some insight into how that transferred in terms of processing emotion. Well, I looked at previous research findings. I used a theory, and I had a particular behavior that I was measuring and a particular question, which was basically emotion. So how did I then design this study? So you need to have, that was my research question. When you have a hypothesis, you have to have support for your hypothesis. A hypothesis is a prediction. So I had a theory, which was perceptual narrowing, and I developed a hypothesis that 9-month-old infants would have difficulty in processing emotion from African American faces, but not from Caucasian faces. So then I carried out the research. An operational definition of the hypothesis. It's really important that we sort of define everything, that we follow the same steps that every study would be, just like I talked about before. I selected a research method that was consistent with previous studies. So I used event-related potentials, I used visual paired comparisons, putting two faces side by side. I collected the data. Every subject's data was collected the same way as the other one. It was randomized. There was a protocol. I followed the system. I analyzed the data and I communicated the findings. In my communication about the findings, I did not say that babies were racist. I said that the results suggested that there was a perceptual bias, and this was supported by previous research. So I was able to say that my findings supported my hypothesis. So when I give this idea of what is a theory, it's a broad explanation. It's predictions concerning the phenomena of interest. So for me, it was face processing. And I used the theory of perceptual narrowing. That helped me guide my prediction. So, as I was saying before, a prediction, which is supported by a theory and previous research, it needs to be tested. You can have many different research questions, but in order for it to be a hypothesis, it has to be testable. You have to be able to collect data to support or not support and reject your hypothesis. And within each one of these hypotheses, this idea of operational definition, this is a really, is a really important thing to note here. This is sort of what keeps everything in protocol. So, and I think the book does a nice job in sort of, in their own words, talking about this. When you communicate your findings and share them, there are different parts that you share. You share the results itself. You share them in perspective of what you, of how the data relates to your hypothesis. So was your hypothesis supported or rejected? And then you also sort of, some of your data may not make sense. So you may be able to say it was observed that 5-month-olds could not match emotion, like I found, from Caucasians or Caucasian faces or African American faces. You may get an unexpected result. You may have lots and lots of theories and research to support your data, and you don't replicate other findings. And also it gives you a space to develop ideas for future investigations. And lastly, I think it's important to say this over and over and over again. A hypothesis can never be proven because a theory can never be proven. So experimental findings can either support or reject a hypothesis. So, bearing all of this in mind, let's go to the next module, which is conducting psychological research. So we're going to look at what research methods do psychologists use, and how do psychologists establish cause and effect relationships in research studies. So there are many different kinds of research. Let's start with the simplest, and then we can get to more complex. But in general, research is a systematic, again, there's that systematic word, inquiry aimed at the discovery of new knowledge. And research builds on other research, and so it's this continually evolving story with the same pattern and the same steps, which allows it to grow. We saw a little bit of this in chapter 1 when we were looking at the roots of psychology. Other people built off of other theories, so everything is connected. So, when we think about some of the most basic research, descriptive research is sort of a systematic investigation of a person, group, or pattern of behavior. And so this, excuse me, sorry, technical error. So you can see up here these pictures of little Albert. And little Albert and the white rabbit was this little boy. He actually was an orphan, I believe. And there are many ethical dilemmas about this situation. But they took this baby and they they taught him to be afraid of white things. At first, he saw the rabbit, and then they paired the rabbit with a large sound. And he ended up being afraid of everything white, including Santa Claus and so forth. But it was a systematic investigation of, can an infant be trained to be afraid of things that are categorized as white? Archival research is, and this is often done in clinical psychology, is sort of looking back at patterns in data. It's inexpensive, but the data may not be in a form that allows the researcher to test the hypothesis, meaning that the researcher has very little control over the data, but there is a plethora of data to support it. So the next sort of step is naturalistic observation, which is that you're just observing. So you can, one of the major advantages is that you can look at something in a natural habitat, but one disadvantage is that you have an inability to control any of the factors of interest. So two examples that I like to give are, so you can look at mating habits of the antelope in the Arctic plain. You can also look at paint color and teenage mood outburst and control in schools. So there have been research studies that say that if a room is painted lavender, it's more likely to promote a quieter, calmer environment. However, that was just looking at the number of outbursts in a lavender room versus the number of outbursts in a green room. And they had no control over who was in the classrooms, what happened in the classrooms, and so forth. Survey research, also another great avenue. You can ask people questions about their behavior, thoughts, attitudes. However, the sample needs to be representative of the population you're trying to test, and the survey people may have a bias or may not be responding honestly. In terms of a case study, it is only unique to that individual, so you can only generalize so much. So correlational research is different than cause and effect, and it's different in the sense that the research is only looking at an association. So does the behavior change in some way when X happens? So one example is that there's a study that I love that looked at patients who had a stroke and developed aphasia, and then they did two different types of treatment. One was a sing-song speech therapy, and the other one was a traditional speech therapy. And what they found was that the sing-song speech therapy was more effective, and the patients were able to communicate. However, they also found that there was just an on-site or not an on-site, but that a lot of the patients developed depression. This research was able to say that if a person has a stroke and aphasia, they may develop depression, but they cannot say that the stroke and aphasia caused the depression because they did not manipulate anything to see if depression was an effect. Another great example of this is you can look at stress level of parents and children whose children are hospitalized, right? And you can also look at the length of stay or the severity of the illness. And you can look at the association between those two. But you cannot say that if a child stays in the hospital for more than 30 days, a parent's stress level, it causes the parent's stress level to be higher. So you can look at the direction, as they say here. So I would imagine that when we talk about parent stress level when a child is sick, that the longer they're in the hospital, the more stress the parent is going to feel, or the shorter the time that the child is in the hospital, the less stress they're going to feel. Experimental research. So this is sort of my area of interest and expertise, I guess, is that you are doing an investigation of a relationship between two or more variables by testing a hypothesis, and you are measuring the effects of a change. So that change is called experimental manipulation. this is one of my slides that I put in there. So research design, translate the objective study uh, of the into concrete details of an investigation. So the skeleton of a research study has, you have the research question, which is then translated to a predictive statement and the hypothesis. You have an independent variable, which is the one that's being manipulated. So if we go back to the study that I was talking about with race and emotion processing, the independent variable was was race, um, and the outcome measure was the collection of the data I was using to try and see if I could answer and test that hypothesis, which was neurological data and visual looking patterns of children. So the statistical analysis examines the changes in the data collected as a result of changes in what's being manipulated. So I looked at the brain activity of infants when they were looking at a face that an African American face when they were hearing a happy face when they were hearing an African American. Sorry, let me rephrase. I looked at faces, the neurological data of infants when they were looking at African American faces that were happy paired with a happy sound, and the same for Caucasian. So I was able to sort of look at the data in particular points of time. When you are doing experimental research, it's important to think about, especially in the clinical world, and when you're thinking about treatment, that there is the experimental group and there's the control group or the placebo. We've talked about what an independent and a dependent variable is, but this is a nice definition, I think. So if you sort of going back to basics, you can certainly use this information. So one way that I like to think about research, so far we've discussed sort of general principles of what is psychological research, what types of questions can be answered, what methods can you use. But what I like to sort of go to now is thinking about what are these steps. So if you think about it in terms of a full cycle, so the research question is, what are you interested in? The hypothesis is, what are you testing? The how is, what research design are you going to use to test that hypothesis? Who, this is sort of designing the research and implementing it. Who is the sample? How and what? What variable is going to be manipulated? What method are you going to use? Are you going to use behavioral data? Are you going to use neuroscience data? Are you going to give them a survey? What results will you be collecting? And then why? Why is this important? So we reflected on this before, and I sort of talked about how I was looking at a racial bias, a perceptual bias, and then the media took it as the babies were racist. So this I will leave up here, but for some students who are learning about research and need to take a step back, I love Grey's Anatomy. And so if you think about a mini series in TV, they follow a similar structure, right? So every Grey's Anatomy episode starts with a question, and the questions are always similar of, can surgeons be in love and be successful in their career? Well, Meredith starts with a general question, a monologue. Then there's a specific problem or a specific issue between a couple. So, Meredith wants to know whether she can work with Derek when she's, will they have better outcomes in their surgery because they're in love? So the research design, and this is where you sort of have to tailor it to what TV show you like to watch, but is you can look at how are they going to evaluate this. So in Grey's Anatomy, they could look at surgical mistakes, death counts of surgeries, who's involved. It could be nurses, it could be surgeons, it could be patients. You know, how are you going to observe this? So what are you going to be manipulating? Are they using a new surgical technique? Is the communication between surgeons changing? And then, to be silly, but to illustrate the point, is that the what, we always go back to the hypothesis here of, can surgeons be in love? Surgeons in love will have better outcomes, right? So we look at, are the surgeons still in love? Did the patient survive the surgery? Now, if we stopped at that point, it would be pretty boring. Because what's really interesting is its implications and conclusions. So we want to know if Meredith and Derek are in love, or why it's hard to be in love. We want to know what the unanswered questions are. We don't care that just the patient lives or dies. We want to know, did they reunite with their family after the surgery, or whatever detail is sort of relevant. Experimental research, like I was saying, there's a system, there's a hierarchy, there are steps, and one of these steps to sort of have a clean, strong research study is to have a random assignment. So all of the babies in my study were randomly assigned to condition A or condition B, which meant that the pictures and sounds were shown to the child in a different order. A significant outcome is if you have a p-value of 0.05 or less, and that means that it's a meaningful outcome. Replicated research, I think the video for the media reflection talks about this too, and we'll hear about it in a little bit, that research that has been replicated often will increase the confidence of the hypothesis or the theory itself. So we're going to listen to a short NPR clip, and I believe that I have, there is a transcript here, so I believe that I have posted it on the website, but I will make sure to do that if not. So let's just listen to this.
Next, we're going to report on scientific research, in particular on the way that reporting on scientific research face pressure to publish new discoveries, which in turn might influence what they study, and that, of course, is not necessarily a good thing. There's work being published today that's part of an effort to fix this problem. NPR's Shankar Vedantam joined our colleague Steve Inskeep to talk about it.
Shankar, welcome back.
Good morning, Steve.
Okay, so what's wrong with a pressure to publish particular findings as you discover them?
Well, the problem is that the incentives in science today are all about breaking new ground, and there's much less incentive to making sure that the ground you're standing on is actually solid. Most people think about science as being about breakthroughs, but science really is about the gradual accumulation of knowledge and retesting what we think we know. I spoke with psychologist Brian Nosek at the University of Virginia. He's been working on this issue for a while.
The issues are pervasive. In every science, scientists are rewarded for publication over accuracy. There isn't a culture of replication across most disciplines. We're not rewarded for redoing what someone else does. The main reward is for doing something novel.
rewarded for publications over accuracy. I guess we should explain that scientific findings are published in prestigious journals, and it's a big deal when your findings are published there.
It can make or break your career, and so especially if you're a young researcher, the pressure to come up with a publication is extraordinary. Now, Nozick is the editor of a journal called Social Psychology, and this is a field where some recent results have been called into question. And the way that journals typically work is the scientist does a study, writes it up, sends it to the journal sends out the study to peer reviewers who review the study, and if they give the okay, the journal considers it for publication. Nozick thinks this model creates perverse incentives, because if a study confirms an older result, the journals tend to say, well, we knew that already, it's not a novel finding, and they're less inclined to publish it. Now, if the replication contradicts an earlier finding, when the journal sends out the study to the peer reviewers, some of the peer reviewers might have been the researchers who conducted the original study, and they can now find ways to shoot down the study and reject the study and say we shouldn't be publishing it anyway. And so what this does is it creates a disincentive for researchers to conduct replications at all.
And this is how you're supposed to figure out that science is true, by doing the experiment again and again and again.
That's exactly right. So in this current issue of the journal Social Psychology, Nozick turns this model on its head. Every article that's in the journal is focused on replicating an earlier study, and there's a second innovation. All the replications were accepted for publication before they were conducted. So the peer reviewers only looked at the methodology of the study, and if the science was solid, the study was guaranteed publication. Nozick thinks that this creates the incentives to do the best science, not just come up with the sexiest result.
Okay, so they're trying to repeat old experiments and see if they discover anything. Did they find anything?
They found lots of things that are interesting, Steve, but let me give you one specific example. In 1999, the researchers Margaret Shee, Todd Petinsky, and Nalini Ambadi came up with a classic experiment. They were looking at how stereotypes affect how people behave, not the people who hold the stereotypes, but the people who are affected by the stereotype. This study was looking at how Asian women perform in math tests. There's a common stereotype that Asians are good at math, and there's also a common stereotype that women are not good at math. When the researchers reminded the volunteers of either their Asian or their female identity, distinct differences in performance emerged.
So what I want to point out here about this is that they describe the specific question of the research, how Asian women perform in math tests. And they were talking about stereotypes and the specific thing that they were measuring and what was being changed. So what was being manipulated. So we know that the dependent variable here is math performance. We know who our sample is, which is Asian women. And the researchers are changing and manipulating the identity that they're being reminded of. So whether they're Asian or they're female. So now let's listen and hear them talk about what they found.
Here's Nozick again.
Asian women who were reminded that they were Asian performed better on the math test, whereas Asian women reminded that they were women performed worse on the same math test. Something that seems like it shouldn't be flexible, how well we perform in math, is flexible as a function of the identities that we have in mind and stereotypes associated with those identities.
Wow, that's an amazing finding, but you're saying that under this new model, someone went back and tried that experiment again. What did they find the second time?
Well, that's exactly right. Alice Moon and Scott Reeder at UC Berkeley redid the study in Northern California, and they found the effect did not hold. Now, our first reaction is to say, look, the original study was debunked, but it turns out the answer is actually more complicated than that, because there was a second replication.
So what I think is important here is that the original study was debunked means that the hypothesis was not supported. It couldn't be replicated, so therefore the theory was not probable in explaining the behavior of the women taking the test. However, it's complicated, and we're going to find out why.
At Georgia Southern University, Carolyn Gibson, Joy Losey, and Christine Vitiello confirmed the original study. Our tendency, Steve, when we hear scientific results is to draw simplistic conclusions. Look, we have a breakthrough. Look, the breakthrough has been debunked. To me, what the replications are doing is open up questions we actually hadn't considered. In this case, the fact the replication failed in Northern California but worked in the Deep South raises questions. Is the effect due to demographic? Is it because of geography? Is it something else? And now we are forced to be curious rather than judgmental.
I guess this is a reminder that you need to keep an open mind and how subtly you can close your mind without realizing it.
And in many ways, Steve, that's the point of science, to recognize that beneath what we think we know, there are layers and nuances that are waiting to be discovered.
Shankar, thanks very much.
Thank you, Steve.
That's NPR's Shankar Vedantam. You can follow him, as always, on Twitter at Hidden Brain. You can follow this program at Morning Edition and at NPR Inscape, as well as at NPR Green.
So the next sort of area of research, when we're talking about who we're working with, what questions we're answering, what does the results mean, is that we have to ethically treat the participants well. So that means that they have to be protected from physical and mental harm. We know that they have to have privacy and confidentiality in regards to the information they provide or the behavior that's observed. They need to know that participation is entirely voluntary. They need to know and be informed and give consent about the nature of the procedures. So they need to have an understanding of what's involved in participating in the experiment. And that all experiments must be reviewed by a panel before being conducted. So here at the which is called the Institutional Review Board. So informed consent is basically a document that says, I've read this, I understand this, I know it's voluntary, and I'm willing to participate. So there are some vulnerable research populations, one of which is infants and children, also prisoners, disabled, or people with special needs. I think in particular, I want to talk about ethics. We're going to listen to a story about identical twins, which is, again, this is another NPR story, so we'll head to that place. And I believe that the transcript will play as we go along. So we'll just listen to a bit of it, and I will post the transcript or the link so that people can listen to more if they want.
From NPR News, this is All Things Considered. I'm Robert Siegel. What is it that makes us who we really are? How much do our life experiences play in determining our identity? How much does our DNA count? Paula Bernstein and Elise Shine were both born in New York City. Both women were adopted as infants. They met for the first time when they were 35, and they found that they were identical strangers. Their story comes to us from producer Joe Richmond of Radio Diaries. We hear them tell it in their words.
My name is Paula Bernstein. I grew up in the picture-perfect childhood in suburban Westchester with really happily married parents. I got married. We had our first child. And really, we were kind of in the nesting stage of our life. And then it was a spring afternoon. I was just rushing in the apartment with my daughter. And I walk in the door and the phone is ringing. And I look at caller ID and it said Louise Wise Services. And I had always known the name of the agency where I was adopted. And, my heart kind of started to beat quickly. And I thought, why would they be calling me after all these years? And the woman on the other end of the line confirmed that I was, in fact, Paula Bernstein, and I was adopted from Louise Wise. And then she said, well, I've got some news for you. I thought I should tell you in case you were walking down Fifth Avenue and ran into someone who looks exactly like you do. And then she said, you've got a twin who's looking for you. And she at that point said, I hope I did the right thing in telling you. Are you prepared to hear your twin's name? And I said, yes. And she told me her name, and I thought, I have a twin, and her name is Elise Shine.
My name is Elise Shine. I was living in Paris and Paula was in New York. So, I head off to New York and we arranged to meet at a nearby cafe in the East Village. I was very nervous about what I was wearing. How do you dress to meet your identical twin for the first time? Well, I was sitting on the terrace. It was a gorgeous spring day, and I was wearing sunglasses and, nervously chain smoking. And then, suddenly she saw me. I came over and said, Elise, and she got up and we kind of gingerly patted each other, which was funny. There was no tearful hug. And then we began to inspect each other. It was like, monkeys in a zoo that we were kind of inspecting each other's bodies. And I remember I said, do you have chubby knees? And I kind of glanced down below the hem of her skirt and saw that her knees were quite cute. And I always thought of mine as kind of chubby. So I thought, well, why did she get the cute knees? It was just a natural instinct for us to start comparing. We had 35 years to catch up on. How do you start asking somebody, what have you been up to since we shared a womb together? Where do you start? Very soon after Elise and I reunited, I said, do you know why we were separated? And she said, well, the woman at the agency said we were separated for a study on nature versus nurture. The only study of its kind on separated twins from infancy. When the families adopted these children, they were told that their child was already part of an ongoing child study, but of course they neglected to tell them the key element of the study, which is that it was child development among twins raised in different homes.
So I think it's important to point out here that they did not get informed consent. The researchers did not get informed consent from the parents involved. They did not give them full disclosure of what was the nature of the study and the implications of it.
My name's Lawrence Perlman, and in 1968 to 69, I was a research assistant on Dr. Peter Neubauer's study of twins reared apart. Apparently, Viola Bernard, who was a very prominent child psychiatrist and a consultant to Louise Weiss Services, the adoption agency, had a really strong belief that twins should be raised separately. This idea that twins were often dressed the same and kind of treated exactly the same, she felt interfered with their independent psychological development. So she had mentioned this to Peter Neubauer, who was a very prominent child psychiatrist, and he said, oh, there's a great opportunity to do a research study, and that's how the study was born. And Paula and Elise were newborns, so I had seen them in their foster care. So at that time they were called Marion and Jean, which I guess were the names that their mother had given them. And these are some notes of the visit that I did when Paula and Elise were 28 days old. Jean tends to be more active than Marion, wakes sooner, cries more lustily and persistently, and is less easily diverted. They seem advanced for their age.
They eat heartily and are ready to take solid foods, sleep soundly, and can even be moved about and taken outside without disturbing their sleep. It's hard to look at this and realize that I was this foster child who, for the first 5 months of my life, really lived with my twin sister.
Since the beginning of science, twins have offered a unique opportunity to study to what extent nature versus nurture influences the way we develop, the people that we turn out to be. My name is Lawrence Wright, and a few years ago I wrote a book about twin studies that was called Twins. Every other twin study that I'm aware of, especially of identical twins who have been separated at birth, is retrospective. Usually the twins are discovered, oftentimes in the middle of their lives. The Neubauer study differs from all other twin studies in that it looked at the twins at the beginning of their lives. They were filmed as they were struggling to their feet the first time. They were filmed as they went out on a bicycle for the first time. Their intelligence was assessed, their personality, all of these things were measured. And no one, neither the twins nor their adoptive parents, realized that they were adopting identical twins separated from each other. from a scientific point of view, is beautiful. It's practically the perfect study. But this study would never happen today.
So the study ended in 1980, and then a year later, New York State began requiring adoption agencies to keep siblings together. At that point, they realized public opinion would be so against them that they wouldn't dare publish the study. It's kind of disturbing to think that all this material about us is, in some file cabinet somewhere, and really for ourselves, we had to figure out what the true story was.
So what I love about this story is that it demonstrates the research question, the hypothesis, how they did the study, but also sort of in a bigger context, what it meant. So ethically, there were so many violations of the, there was no informed consent. The data actually wasn't even used, and now it's just sitting in a filing cabinet. And so you really, what I take away from this example is you need to think about, was it worth doing the study? Did it do harm? Did it provide answers to a question that was important to ask? So, experimental bias, I think that if you think about Peter Neubauer, he was influenced by someone else, the woman who thought that twins needed to develop independently. So you have to really think about that. And in other types of studies, there's something called the placebo. So it is, if you think about a cancer research study of a treatment, some people are randomly assigned to the treatment group, some people are assigned to the placebo group. Or a child that has a learning disability may be trying a new medication, and they want to see if the one medication is actually more effective. So they may get some children may get the medicine and some children won't. One way to control this to avoid experimental bias and improve the validity or the generalizability of this study is to do something called a double-blind procedure. So that means the doctor prescribing the drug or the person giving the drug, as well as the participant receiving the drug, has no idea what they're getting. So that's the end of our lecture today. Thank you for your attention, and I look forward to talking to you about neuroscience. The neuroscience lecture will be posted by Friday. I am waiting to get statistics from the website to see about what concepts are difficult so I can make sure to cover those in my lecture. Have a good night, and I look forward to working with you soon. Take care.